Underneath the most hostile frozen environment on Earth, something massive is hiding. Deep below the ice, a structural anomaly is actively manipulating the surface. For years, researchers surveying the Hudson Mountains in West Antarctica kept stumbling across scattered boulders of pink granite sitting right on top of the snow. Geologically, these rocks belong anywhere but here. The Hudson Mountains are volcanic. They are composed entirely of basalt and ash. Granite forms deep underground through the slow cooling of magma, meaning it is physically impossible for these pink boulders to have formed naturally on these peaks. These mountains sit right next to the Pine Island Glacier. This specific region of West Antarctica is actively losing ice faster than almost anywhere else on the planet, fracturing and sliding toward the ocean at an accelerating rate. Tracking exactly how those impossible granite boulders reached the top of a volcanic mountain range provides the data needed to calculate how quickly the ice holding this glacier together will fail. To trace the origin of the boulders, scientists used a technique called UPB zircon dating. They extract microscopic crystals trapped inside the rock and measure the exact rate at which radioactive elements have decayed into secondary particles. The decay patterns revealed the granite formed 175 million years ago. That places its origins squarely in the middle of the Jurassic period. When that rock solidified, the continent of Antarctica was completely free of ice. It had a mild, temperate climate, capable of supporting dense, cold-tolerant forests of conifers and ferns. Large animals thrived in this environment. The fossil record shows 23-foot-long crested dinosaurs and two-legged, long-necked herbivores actively navigating through these southern forests. Today, those forests are buried under miles of severe cold, brutal winds, and thick ice. A landscape that once supported massive reptiles now sustains only a few hardy lichens and mosses. Earth's climate is capable of profound, total flips. Finding the age of the rock didn't explain its location, so in October 2025, the British Antarctic Survey sent research planes to systematically scan the unseen bedrock lying beneath the Pine Island Glacier. They used gravity scanning. Because different types of rock have different weights and densities, they pull on Earth's gravity in slightly different ways. By measuring those micro-fluctuations, the team mapped the exact mass hiding beneath the crust. The instruments detected a monolithic chunk of granite buried deep beneath the ice. This hidden block measures roughly 60 meters wide and 4 meters thick. Millions of years ago, when the Antarctic ice sheet was much thicker and heavier, the expanding glacier violently scraped against this granite floor. The moving ice tore off large chunks of bedrock, carried them for miles, and deposited them entirely uphill onto the peaks of the Hudson Mountains. That massive buried granite block acts as a physical sliding board. The specific density and smoothness of that rock dictates the exact friction levels, and therefore the speed of the modern glacier as it grinds toward the ocean. While the bedrock controls the slide, the real threat is happening in the water. In 2024, researchers deployed a robotic submarine called RAN to map the underside of the massive ice shelf holding the glacier back. The submarine dropped into the dark, freezing waters, navigating the complex geometry of the submerged ice. And then it suddenly went completely silent, lost forever. But before it vanished, RAN transmitted its final images back to the surface. It captured perfectly spaced, geometric step patterns and precise teardrop shapes carved directly into the ceiling of the ice. These deliberate-looking shapes are the physical scars of rapid decay. Massive volumes of warm ocean water are surging beneath the shelf, carving away the underside of the glacier and hollowing out its structural support. The hidden granite shows us how the ice slides mechanically, but these deep underwater scars prove that the ice shelf is already actively disintegrating from the bottom up. If Antarctica was warm enough to support forests 175 million years ago, we have to look at the exact mechanism that caused it to freeze over entirely 34 million years ago. This chart shows global atmospheric CO2 levels against average global temperatures. Over millions of years, natural tectonic processes pulled carbon dioxide out of the air and locked it into the Earth's crust. As CO2 levels steadily dropped, the atmosphere lost its ability to trap heat, and global temperatures plummeted in direct response. At the same time, continental drift physically separated South America from Antarctica. This movement opened a deep water gap known today as the Drake Passage. With the land masses separated, ocean water could flow completely uninterrupted around the pole. This created a violent, non-stop circular current that acted as a massive thermal wall, permanently blocking warm waters and moist air from reaching the continent. The global climate state is entirely malleable. With enough time and shifting carbon levels, the Earth's environment will transform completely. The ancient cooling took millions of years. Today, human activity is rapidly pumping huge volumes of carbon dioxide back into the atmosphere, rapidly trapping excess heat and reversing that deep time process. The Earth's oceans absorb roughly 91% of that extra heat. That steadily warming water is what is currently washing against West Antarctica, aggressively melting the Pine Island Glacier from below. The destruction of this glacier is a direct threat to global coastlines. As the ice melts and slides off the hidden granite bedrock, it adds massive volume to the ocean, pushing water directly onto the streets of coastal cities like Miami. Thousands of miles away, cities like Bangkok are already actively dealing with the physical realities of the ocean's expansion. The Jurassic fossils hiding under the ice prove that Earth can lose its poles. The climate will react to what we put into the air. Subscribe to the channel for more deep dives into Earth's history, and click the video on screen right now to see exactly what happens to the global map when the Pine Island Glacier officially collapses.